All right, we're going to be on section 10.5, which is on parabolas. And you're going to see parabolas a lot in the world. We have some famous parabolas like the St. Louis Arch in St. Louis, Missouri. A lot of times you see arches as a part of roller coasters, and probably the same famous parabolas, which are also known as arches, are, well, in an iconic visual that many people know all over the world. After today, we're going to use and determine the standard and general forms of this equation of a parabola, and we're going to work on how do we graph a parabola. So let's talk about what we already know. We've seen circles, and circles are all the points which are equal distant from one point in a plane. We've looked at ellipses, which are all the points for which the sum of the distances from two foci to every point on the curve is constant. So it's like the addition of the two sums are always going to be the same value. It's always going to be a same constant value. And then a hyperbola, where it's the difference of the distances from two foci to every point on the curve, is a constant. So it's when you subtract the two values that you always get a constant value. And then the last thing is we're working today, we're investigating a parabola, which are all points that are the same distance from a focus, which is a point here, and a line called a directrix. So you can have your focus and your line here. So it's all the distance, all the points that are the same distance from this focus and this line. So this distance from the line here might be, oh, this might be a distance of 2, and this would be the same from the focus, a distance of 2. If I picked another point, and this kind of comes up like this here, this has a distance from the line of, let's say, 5, and it should be the distance from the focus should be that same 5. And so what happens is it kind of comes like this. It kind of turns out to be a parabola that like this. So this might be still a distance here of 5 and a distance this way from my focus of 5. Okay, so we have parabolas that can go opening up to the right. If your directrix is a line like this and your focus is a point here, then your parabola can open up. Okay, so that's kind of the basics of what a parabola is and how we form it. Let's talk about the equations. The equations, we have two different equations for a parabola. And the big difference of a parabola and hyperbola or an ellipse or a circle is that in a parabola, only the y or the x is squared, not both of them. And so we have this form, this standard form of the equation of a parabola is either y minus k quantity squared, and then we say it equals 4p times x minus h, where p is this distance right here from the foci to the vertex, and from the vertex to the directrix. So remember how we said it's the distance. P actually ends up to be the smallest distance there is from the curve to the foci. Okay, and the smallest distance there is from the curve to the directrix, which is always going to be at this vertex right here, at this vertex. So it's going to be p units on either side of our vertex. Okay, so instead of a center point, we have a vertex. And let's talk about kind of how we show some of these things. So this is right out of our book. I kind of like this. I'm going to kind of see everything. So the standard form. And so we have two different values. If y is what's squared, it's going to have an orientation that opens right for the most part. If x is what's squared here, it's going to have an orientation that opens up for the most part. Okay? And then these are really kind of important right here, saying, okay, our vertex is going to be at HK. Be careful if y comes first. I always want to put this value, I always want to make it KH for my vertex, and I have to remember that this is my X value for my vertex, this is my Y value for my vertex, it's my K. So that's always hard for me. The focus is going to be, when it opens to the right, added to your vertex, going to go to the right of our vertex. And the axis of symmetry is going to be a y equals value, and it's actually always going to be y equals k here. The directrix is always going to be x equals h minus p, so it's always going to be p units to the left of our vertex, okay? And if it's going to open to the right if p is positive, it is opening to the left if p is negative. Now, same sort of things when we have an x squared first. It just has a different opening. It's opening upwards or downwards for the p, and their p makes it either go up or down depending. For your directrix, it goes down. For your focus, it's going to go up from your vertex. So there's a little bit of differences there, but this would be very helpful to have written down. All right, so we have an example here. The first thing in my example, so I have some things that I want to find first. So this is kind of really just traditional what we have you find when you're dealing with a parabola. The first thing I might look at is say to myself, what is my p? Because I know this right here, this value 8 would be what 4p is. Excuse me. In the equation, that's what 4p equals. So if 4p equals 8, I'd have to kind of first calculate and say that p equals 2. So my vertex is going to be my HK. So here it's going to be -6, comma 0. Sorry about that. Let's see if I can get it to do what I want. There we go. The focus is P units. Now this one's going to open to the right. So it's going to be P units added to our vertex. So our focus is going to be -6 plus 2, comma 0. Now usually I don't write it like that. What I'll write it down is I'd write it as -4, comma 0. 2 units to the right of our vertex. The equation of the directrix goes 2 units to the left. All right, and again, so what I would do in my head is I'd have my -6, and now I'm going to subtract 2, and I get -8. And so this one is going to be the line x equals -8. And then axis of symmetry would be y equals 0. It always matches. The axis of symmetry matches our value that's our variable that's squared, and that value in our vertex is going to be the same as the line, so it would be y equals 0. So now let's talk about what it would be like to graph this. Let's first graph the vertex. -1, 2, 3, 4, 5, 6. Here's 6, 0. From there, I have to graph the focus, which if you remember is 2 units to the right of my vertex because P was 2. 2 units to the left of the vertex is where we would look for to have that directrix. And the directrix is this straight line. So there's my directrix. Now the question here becomes, how do we know how to graph it? Do we graph it kind of thin like that? Or is it like really wide like this? How do we know how to do this curve? All right, so that's the question, is how do we know how to do this curve? Well, what happens is it's always the same distance from the focus to the outside edge. And so what actually happens is the distance that's here, all right, which here happens to be 4 units, actually becomes the distance 1, 2, 3, 4, going up. All right, and 1, 2, 3, 4, going down. All right, so that tells me kind of where my curve should be. It should be 4 units above that, 4 units below that. And then I can kind of draw my curve based on that. It helps me to know kind of how wide my curve is. So there's a couple ways you can do this. Some people will say, well, this is going to be 2p. It's always going to be 2 times p, whatever you have there. Because the distance from the focus to the directrix is always a p here and then another p here. So it's always going to be 2p. Or some people will say it's the distance from the focus to the directrix is what we know we need to have to go above and below our focus to see how the curve is curving. Okay? Let's go on and ask another question here. All right, kind of I like these types of questions. So we know our standard form. All right, so we know we have our standard form. It's either an x squared or a y squared. And then we have our 4p in there. And really to decide if it's x squared or y squared, what I'd probably do before I even look at the equation is kind of graph what is it going to look like. So this one says, all right, we have a parabola with the vertex at the origin. So I'm at 0, 0. That's where my origin is. And the focus is at 0, -4. 1, 2, 3, 4. So here's my focus. Oh, so if that's the focus, it's opening like this. I kind of have a visual in my head how it's opening. Well, first of all, if it opens left or opens right, what we have for a basis is we have a y plus or minus something squared, and then that's going to equal 2p and an x. Actually, let's do this. Let's call it this way. Let's say y minus k and x minus h here. Okay? So that's what we're going to have if it's going to go left or right. Now, if it's going to the left, there's a couple things we know. We know that p is negative. All right? We also know that HK is our vertex, and our vertex is at the origin at 0, 0. So we could just do this. 0 here, and 0 here. All right? And we know that we have a negative here for our P. So let's figure out what our P is. Well, our P is the distance from the vertex to the focus. So I could think to myself, here I'm at the vertex, and if I go -1, -2, -3, -4, I get to my focus from my vertex. So here we go. This one would be -8, and then instead of x minus 0, I'm going to just call that x. Over on this side, it's y minus 0 squared. I'm just going to call it y squared. That would be my final equation for this particular problem. Let's look at another problem. Write a standard form of the parabola. And again, I think it really did help to graph that. So I'm going to graph it. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I kind of marked that a little bit more with myself. So I knew this one was 7, 5. So 1, 2, 3, 4, 5. So I'm estimating where it is. It really doesn't have to be a really good sketch at this point. There's -7, 5. And the directrix is at x equals -9. Okay, so if that's my directrix and this is my vertex, I know my vertex is going away here. So again, I have a y squared equation. Okay? And what I know is my vertex is here. This is my k for my vertex, so it would be -5. This would be minus a -7. So I'm going to make this +7 right now. The last thing I need to figure out is what is my p? Okay? And p is the number of units from the vertex to the directrix or to the focus. So we know the focus is probably going to be right about here. All right, but we don't have that, so that's okay. So I'm thinking that our p has to be a 2. All right, so our answer here would be y minus 5 quantity squared equals, I'm going to say 4 times 2 would be 8. And I'm going to leave it like this. I'm going to leave it in our standard form. Okay? Now let's look into a problem that we have to put into standard form when it's not given in standard form. So let's look at this one. The first step here is group squared terms on one side. So since it's in this case the y has been squared, I'm going to bring the y squared over and I'm going to bring the minus 2y. And I'm going to bring the 12x to the right side and the 13 to the right side. Everything that doesn't have a y in it, I'm going to bring over to my right side. So it would become a -12x and a -13 on the right side. Now what I need to do is I need to do completing the square. So what I need to do here is I need to add something to both sides. If you remember, you take the coefficient of your y value, you divide it by 2, so it would be -1, and you square it. And that's what you're going to add to both sides. So over here, when I factor this, I would get y minus 1 quantity squared. And over here, when I add the -13 and the 1, I get -12. Now the last thing I need to do is I need to factor the other side. I'm going to factor out here this -12. So technically what I'm doing is I'm dividing this by -12 and I'm dividing this by -12. So that's how I'm going to write it as -12, and then what's left is x plus 1. On this side I had y minus 1 and it was squared. So now I have the standard form of my equation and I can go through the steps that I need to take in order to graph it. So in order to graph this equation now, I'm going to get a little bit bigger graph here for myself, sorry. All right, so I'm going to say vertex. Our vertex here, I'm going to pause it for a little bit, and you're going to kind of see the vertex and the focus equation of directrix and the axis of symmetry magically appear. All right, so we can see that our vertex would be here at -1, 1. From our vertex, our P, I calculated to be a -3, so I'm going to go 3, 2 in the left direction. And then my equation of the directrix, it would be a straight line here. And I can think of it as I took my straight line and I went 3 in the right direction. So I know this is going to open to the left. All right. My equation of my axis of symmetry would be that y equal 1. I can show that here, like we can have our axis of symmetry where it's going to be the exact same on either side of that curve. And then the last thing I need to do is I need to decide kind of how it curves. How does my curve happen? So I go back to my focus and I go 2p above it and 2p below. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5,